Alrighty, in this video we're going to talk about solving a system of equations graphically. So what we mean by that is we're going to have like probably a parabola and a line. We're going to graph them on our graphing calculator and determine their solution set. So if you got your calculator handy, let's take it out. If not, go take it out, go open it up. So here's what a question would look like. It would say to solve the following system of equations graphically. And it might give you two functions. They might be in y equals form. But here's two functions. The first one is our quadratic function. The second one is our linear function. So let's go and graph these in the calculator. So my calculator is right here. So I'll type x squared. I forgot what the rest of the equation was. X squared minus 4x plus 3. X squared, subtract 4x, add 3. Press enter. There's our graph, looking good. So to get another one, let's press tab. And the other equation, I believe, was function 2 was 2x minus 5. Let's graph that. 2x subtract 5. Enter. There's our graph. So you can kind of tell where the two graphs cross. You can tell where the line crosses the parabola. It looks like it crosses it first, maybe right around the vertex. I don't know, though. I'm not too sure about that. But one thing that might help me to see it is if I go to my table of values. So you might remember Control T for table of values. Now, you might remember from graphing before that I kind of like to find the middle of my table. So I know my first column here, this one right here, that's the one that is my parabola. It says x squared minus 4x. So what I'm going to do is I'm going to kind of look through some of those values for a second. Oh, I think I just had it. Yeah, I'd like to show my table where the vertex is going to be. So it looks like here, I can see that my y values are starting to repeat. I'm getting two positive 3s, 2 zeros. There's that symmetry that I like. So when I go to my table of values, I'm going to put my x value of 2 right in the middle of the table. So let's see if I go over here, the middle of my table. How many boxes do I have? I got 1, 2, 3, 4, 5, 6, 7, 8, 9. Holy cow. 1, 2, 3, 4, 5 would be in the middle. So there's where 2 is going to be. And here's some other values. You might be saying, well, mine only has 7 on it. OK, so you only do 7 values. But let's make sure that 2 is in the middle. Now, function number 1. Let's take a look at how that went up. It looks like the vertex was at -1, and then it went to 0, then it went to 3, then it went to 8. It went all the way up to -15, so let's check that out. So at 2, we were at -1. Then we had our zeros. Remember that symmetry of the graph? We like that. You know what I'm just going to do, though, is I'm not going to worry about those last 2. That should be good enough. So now, function number 2. Let's move over a little bit. Boom. Let's get rid of that guy. Let's move our table over a little bit. And there's some other matching values. So it looks like it goes from -7, and then it's going up by 2, as it looks like. Well, that makes sense. Yeah, you might remember like the slope and the y-intercept, things like that too. So let's see, we're at -7, -5, -3, -1, 1, 3, 5. Great. Now, can you just tell, looking at the table, where the solutions will be? Can you see that they're kind of where the y values are the same? So one of my solutions is going to be right here at the point 2, -1, because both y values are -1. And can you also tell the other solution is going to be at 4, 3? Because that's where the y values are both 3. So then for what values of x does function 1 equal function 2? Well, it equals it when we have x equals 2 and at x equals 4. Those are the x values that make the y values equal, that makes the functions the same. Great, so all we got to do now is graph it. So we got our table. Let's go plotting some points. So for the parabola first, we start at 0, negative 1. How about if I look back at the table really quick and see what the table looked like? Let's see. The vertex was at 2, negative 1. Gotcha. So 2, negative 1. And then we had the zeros. And then I think we had the 3s. A nice little pattern emerges. Up at 5, yep. Is that these numbers, these differences between terms go up by odd integers. They go up by 1s and 3s and 5s and so on. So if we sketch that graph, remember, nice smooth curve here. Boom, 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 looks perfect. Love it. Hey, you got to label it, right? Y equals x squared minus 4x plus 3. And the other one was the line y equals 2x minus 5. So that had a y-intercept of negative 5, and then a slope of 2, up 2 over 1. There's one of my solutions, and there's my second solution. We'll go down 2 into the left one a little bit. So there's my green line. Y equals 2x minus 5. And again, we want to identify our solutions. So on our graph, let's write the solutions are 2, negative 1, and 4, 3. Looks great. So we graph our curves, write down a table. If you wanted to for the line, you could have written down that the slope was equal to 2, and the y-intercept, the b value, was negative 5. You could do that if you want. That's good as well. All right, let's try one more. You go ahead, you make yourself a table of values. Type it in just as you see. Maybe press Control-N on the calculator. And see if you can find where the solutions would be. All righty. So let's see. I'm going to go Control-N. I'm not going to save it. Give me a graph. Let's make this graph a little bit bigger. Ba-doo-ba-doo. So now let's see. Our first equation was, let me go back real quick, the square of x minus 2, and then subtract 3. So I'm going to type it just as I see it. The square of x subtract 2. Subtract 3. There we go. There's my graph. And the other one I think was the line 2x minus 8. 2x subtract 8. Oh boy. That's a tricky looking graph. I don't know where that thing crosses. So check this out. Here's something else that we can do. You might remember going to Menu. And let's go to Analyze Graph. And I want to find the intersection. So now for intersection, I want the lower bound. Am I on the left side of where my graphs meet? I sure am. This dotted line here is to the left of where they cross. So I'm going to press Enter. Then it's going to say, OK, what's the upper bound? So now I got to go to the right side. And there we go. Press Enter. Our intersection point is at 3, negative 2. You can grab onto that graph and move it if you want a little bit. And look, it only crosses in that one spot. We say that the graphs are tangent there. OK, so you want to make a table of values. Control and T. Ooh, I see a negative 2 and 3 and 2. Looks like I'm going to be centering my graph right around here. I'll go to the right 2 so I can see the other ones as well. Let's see, do I got a table of values to make somewhere? Nah, I'll just write it out here. So my first function is function f. The next one is function g. Let's see, it looked like my vertex was at x equals 2. So I'm going to put x equals 2 in the middle. We'll go up a couple. We'll go down a couple. And let's see what some of those values were. It looks like we go to negative 3, then negative 2, then positive 1, then positive 6. So negative 3, negative 2, 1, and 6. And we'll do the same thing going the other way. And then y equals 2x minus 8. I know that my slope is 2 and my y-intercept is negative 8. Well, that doesn't help me really too much there. Well, yeah, when x equals 0, I get negative 8. So when x equals negative 1, I have negative 10, and then a negative 6, and a negative 4, and a negative 2, and a 0, and a 2. There we go. So can you tell that there's only one solution there? It occurs right here at the point 3, 2. So now we go to our graph. Let's see, our vertex was at 2, negative 3. So 2, negative 3, there's our vertex. Then we go up 1. We go up 3. 1, 2, 3, 4. The next ones are up at 6, I believe. There's our graph. Nice smooth curve in the middle. Let's label it. And then our line was at y equals 2x minus 8. We'll do that one in red. So we started negative 8. We go up 2. And sure enough, it just gives that graph a little bit of a kiss right there. So it just touches the graph, and then it goes on its merry way. Ugh, that line got ugly at the end. I can't leave that. I'm sorry, I got to clean that up a wee bit. There we go. So for which value of x does f of x equal g of x? That occurs at x equals 3. And what are the coordinates of the solution? How about 3, negative 2? All right, how did your graphing go? Did you like the fact that you could use that intersect choice on the calculator too? And the table is always helpful. The table is always your friend.